Alright, what we're going to take a look at today are trapezoids, isosceles trapezoids, and kites. And we're going to do this using Geometer's Sketchpad. Alright, so very first thing is we want to know about parallel sides. So let's show the measurements of the slopes of the opposite sides. Alright, as you can see, slope AB and slope CD have the same slope, so that means that they're going to be parallel to one another. Alright, but then if you go and look at the other two sides, if you look at AD and BC, they don't have the same slope. So that means that a trapezoid is only going to have one pair of opposite sides parallel. So when you look at options 1 and 2, we're only going to choose option 2 because there's only one pair of opposite sides parallel. Alright, now we got to start looking at what's going to be congruent to each other, because now we're looking at all of these different things about sides. Alright, so let's show the distances of the different sides. Alright, as you can see, the four sides, side CD, side AB, side AD, and side BC, all have different measurements, so that means that none of the sides are going to be the same. Alright, now let's take a look at our angles. So we're going to show our angle measurements. Alright, we've got that ADC is 84. Alright, then we've got that CBA is 43. Alright, then we've got that DAB is 96. And then we've got that DCB is 137. Alright, so the reason why I'm using a different number of angle markings here is because absolutely none of them were congruent to each other. Alright, but if you take a look right here, I showed this calculation that ADC, which is this angle here, plus DAB, which is this angle here, adds up to 180 degrees. And then that CBA, which is this angle right here, and DCB also added up to 180 degrees. And the reason why that's happening is because of my parallel lines. Angle D and A are consecutive interior, and angle C and B are consecutive interior. Alright, so that means that the consecutive interior angles are going to be supplementary. So option number 8 is going to happen. Alright, let's look at the other special things. Alright, so let's skip the median for a second and go down to the diagonals. So here are my two diagonals, and if I measure the distance of them, my diagonals are not congruent to each other in a regular trapezoid. Alright, so I'm still only going to have these two things checked off because there's nothing else special going on with my diagonals. Alright, but now we have this new thing called a median. Alright, where the median comes from, the median is at the midpoint of the two sides. Alright, so what that means is DE is going to be congruent to EA, and that CF is going to be congruent to FB. Alright, let's look at the distance of the median. Alright, so the median is 5. Alright, what I want you to take a look at though is also the length of DC, which was 3, and the length of AB, which was 7. And if you notice, 5 is in between 3 and 7 because that median is going to come from adding the two parallel bases together and dividing by 2. But we're going to take a look at that in a few minutes. Alright, but right now all I can say about a trapezoid is number 2 is true and number 8 is true. Alright, now let's go and look at an isosceles trapezoid. Alright, an isosceles trapezoid, again I'm going to show the slope of the opposite sides, and still these two sides, CB and AD, are not parallel to each other. But if I look at AB and DC, they are parallel to each other. So I'm still going to have, in an isosceles trapezoid, one pair of opposite sides parallel. Alright, now if I'm calling this an isosceles trapezoid, you should know what's about to happen with the length of the opposite sides. If you notice, the two bases that are parallel to each other are not congruent to each other. But if you look at the two opposite sides that are not parallel, those are going to be congruent to each other. So in order to be an isosceles trapezoid, there is one set of opposite sides that are going to be congruent to each other. So when we go look at our chart, Number 5, only one pair of opposite sides are congruent. Alright, let's skip the medians for a second, and let's go jump down at the diagonals. And if I show the measurement of my diagonals, you notice that they're exactly the same. So another property I can check off for an isosceles trapezoid is that now the diagonals are congruent to one another. Alright, let's get rid of those diagonals and let's take a look at that thing that's called the median. Alright, now again, this is an isosceles trapezoid, so I know that my two sides are going to be exactly the same. And if I put my median in there, that means that now all four of these pieces, DF, FA, CG, and GB, would all be exactly the same. And again, if I want to show the distance measurement of my median is 4 centimeters. And again, if you look at the length of the two bases, we have those two bases, or 2 and 6, and 4 is in between 2 and 6. So 2 plus 6 is 8, divided by 2 is 4. So this median is half of base 1 plus base 2. Alright, now, let's get rid of that median and let's talk about the angle measurements. Alright, now if you notice for my angles, I do have some congruent ones in here. Alright, but where there are congruent, ADC is right here. Alright, and then it's congruent to DCB, which is right here. Maybe. Alright, then CBA, which is right here, is going to be congruent to DAB, which is right here. Alright, so now we actually do have congruent angles, but they're not across from each other, they're next to each other. So these are called base angles, just like when we had an isosceles triangle. So we're actually going to throw in one property down at the bottom, that base angles are congruent. Alright, and again, if I look at my consecutive interior angles, so if I look at angle D and angle A, which are these two guys right here, they add up to 180, and then my other two consecutive interior, angle C and angle B, also add up to 180 degrees. Alright, so that means that my consecutive interior angles are still supplementary. Alright, now let's look at a kite. Alright, so a kite, we're going to look at the slopes. Alright, as you can see, none of these slopes are the same. Alright, so I have no parallel sides. Now we're going to measure the lengths of each side. Alright, if you notice, I have CD and DE are both 4. Here is CD, here is DE, and then it says that D, CF, and FE are both 9. So CF is going to be congruent to FE. Alright, now these are not actually opposite, but we are going to have two congruent parts of our kite. Alright, now let's show let's measure each angle. Alright, if you measure each angle, as you can see, there are two non-congruent angles and then there are two congruent angles. The two congruent angles are angle DCF, which is right here, and then angle DEF, which is right here. So the two angles that are congruent to each other are the angles that connect the non-congruent sides. So DE is not congruent to EF, and DC is not congruent to CF. So at C and at E, that's where my angles are congruent. So I actually have one set of opposite angles congruent. So in a kite, I have only one pair of opposite angles congruent, which is choice number 7. So a kite has number 7. Alright. We can't have consecutive interior angles supplementary because we don't have any parallel lines. Alright, all of our vertex angles are not right. So now let's go in and take a look at our diagonals. Alright, so here are my diagonals, and if you notice, one of them is 11 and one of them is 4, so they are not going to be congruent to one another. Alright, so now that we have all of that going on. There's nothing special about my diagonals in there. Oh, wait a second. Now we're going to look at where my diagonals intersect at point G. So I'm going to show those angle measurements, and as you can see, those are all 90 degrees. Alright, so what that means is, in a kite, well, it's not going to work, but in a kite there would be a right angle in every angle inside of there. So that means I can check off my last property about kites, which is that the diagonals are perpendicular to each other. Alright, so now let's start using our flow chart again to show how our properties compare. Alright, so the reason why we are now in a different branch of a quadrilateral is because when I talk about a trapezoid is not a parallelogram because it doesn't have two sets of parallel sides, it only has one. But I can have a special trapezoid, which is an isosceles trapezoid. In addition to all of that, I could have a kite. I can't consider a kite a parallelogram because it doesn't have parallel sides, and I can't consider a kite a trapezoid because it doesn't have any parallel sides. So let's start taking a look at some examples. Alright, let's start filling in some of our properties. We have that AB is parallel to DC. Alright, we have base angles are congruent to each other, so these two guys are congruent. Also up here at angle A and B, those are going to be congruent to each other as well. Alright, then, since this is an isosceles trapezoid, that means the two sides that were not parallel are congruent. So AE is congruent to ED, is congruent to BF, is congruent to FC. Alright, now if you notice where this median is, this is also going to be parallel to the two bases. So that means I'm going to have more congruent angles because I have corresponding angles. Angle D is going to correspond to angle AEF, and angle C is going to correspond to angle BFE. Now I also know that angle A is going to correspond to DEF, and that angle B is going to correspond to angle EFC. Alright, so now that I have all of that in there, I can start finding some measurements. Alright, so we have AB is 4, we have EF is 8, we have AE is 6. Alright, let's do the easy part of this. And if AE is 6, that means all of these parts of the sides are going to be 6 as well. So ED is 6, BF is 6, FC is 6. I can find AD because AD is going to be the entire side, which is 12. And then BC is the other entire side, which is congruent to that, which is also going to be 12. Now all I have left to find out is what DC is. Well, I know that EF is my median, and my median is equal to half of base 1 plus base 2. Well, my median is 8, so it's equal to 1/2 of 4 plus whatever my second base is, so 4, we'll call it base 2. Alright, so now in order to solve this right here, I need to get the 1/2 out of there, so I'm going to multiply both sides by 2. So I get 16 equals 4 plus base 2, subtract 4, so I get that my second base is going to be equal to 12, so this is going to be 12. Alright, again, because 8 is in between 4 and 12, 4 plus 4 is 8, 8 plus 4 is 12, so I know I did this correct, so DC is going to be 12. Alright, now we're going to go in and we're going to look at some angles. Now we're going to take a look at the angles. So I gave you that angle EAB is 122, so here goes 122. Alright, well we've already marked all of the things that are congruent. So I have my two base angles that are both 122, and my corresponding angles that are going to be 122. The only thing I have left to figure out really is angle D. Well, these two angles right here, since they are consecutive interior, they're going to be supplementary. So to find angle D, I'm going to do 180 minus 122. And when I do 180 minus 122, I get 58. So that means that angle D is 58. Angle C is also 58. Angle AEB is also 58. and angle BFE is also 58. So now I can go down here and plug in all my missing values. Alright, let's take a look at another example. So here I have my bases of my trapezoid. Alright, this actually is not an isosceles trapezoid because if you notice, these two parts are congruent and these two parts are congruent, but they're not congruent to each other. But that does not matter because my median relationship is still going to be exactly the same. So the median is equal to half of base 1 plus base 2. So here my median is 43. So 43 equals 1/2 times base 1. Base 1 is 3x plus 3 plus base 2, which is 7x plus 3. Alright, so that means very first thing I want to do to get all of this simplified, but I also can go ahead and multiply by 2 over 1 on both sides, so I can get rid of this 1/2. So 43 times 2 is 86, so I get 86 equals, combine my like terms, so 3x plus 7x is 10x, and then 3 plus 3 is 6. Now it's a two-step equation, so I'm going to subtract 6 on both sides, so I get 80 equals 10x, divide both sides by 10, and I get x is equal to 8. Alright, now let's take a look at these other non-isosceles trapezoids. So again, my two bases and my median will be parallel to each other. So I'm going to have 29, which is my median, is equal to 1/2 of base 1, which is 23, plus base 2, which is 11x plus 2. Very first thing I want to do is get rid of this 1/2, so I'm going to multiply both sides by 2, and so I get 29 times 2, which is 58. So 58 equals, combine my like terms, so 23 plus 2 is 25. Two-step equation, so I'm going to subtract 25 on both sides. So I get 33 equals 11x, divide both sides by 11, so I get x is equal to 3. Alright, now on this non-isosceles trapezoid, so again that means my two non-parallel sides are not going to be congruent to each other. I have angle A and I have angle B. Alright, well these are not congruent to each other. The relationship is if I have two parallel lines, my two consecutive interior angles are supplementary, so they add up to 180. So I say 11x plus 8 plus 95 equals 180. So 95 plus 8, when I combine my like terms, is going to be 103. So I have 11x plus 103 equals 180. Subtract 103 on both sides. So I get 11x is going to be equal to 77. Divide both sides by 11, and you get that x is equal to 7. Alright, and last but not least, let's look at some missing measurements of a kite. Alright, let's start with just the sides. Alright, so I know that two sides right next to each other will be congruent. These are not opposite, they're just one after the other. So we have AB is 8, we have DA is 14, we have AE is 6, we have BE is 5, and we have DE is 12. Alright, so if AB is 8, that means that BC is also going to be 8. And if AD is 14, CD is also going to be 14. Alright, so that means that AC is this whole thing right here. Alright, one thing about kites is, about the diagonals, is they don't bisect each other, but one of them is being bisected. So this one right here, going from A to C, is actually being bisected. So this is going to be 6 as well. So that means that CE is 6. Well, now with all of this, I know that AC is 6 plus 6, which is 12, and DB is going to be 12 plus 5, which is going to be 17. Alright, now let's get rid of all of this mess so that we can go in and we can start looking at the angles. Alright, one thing about the angles is that we had two angles that were going to be congruent to each other. The way we found the angles that were congruent to each other is we had to go in and we had to first know the sides that were congruent. So we know that AB and BC are congruent. We know that AD and CD are congruent. So the angle that connected the non-congruent sides are congruent. So right here is an angle, angle BAD, connects two non-congruent sides, so it is congruent to each other. And then also BCD connects the two non-congruent sides, so they are congruent to each other. Alright, also the diagonals are going to be perpendicular to each other. So that means that in the middle, I'm going to have 4 right angles. Alright, now I gave you two things. I told you that DAE was 63. So this is 63. I also gave you that EAB was 39. Alright, now if I want to go in and start figuring out some other angles, I know that DAB was congruent to DCB. So just like 63 over here is going to be on the same side, 63 over here, so since DAE was 63, DCE would be 63. And since BAE is 39, BCE is also 39. Alright, now I have a bunch of triangles, and the triangles that I have are right triangles. So if you take a look right here, I have a right triangle. Alright, so in order to figure out what angle EBC is, I'm going to have to do 90 plus 39. And when I do 90 plus 39, I get 129. So to figure out this guy right here, I'm going to have to do 180 minus 129, and that's going to give me 51. Alright, well, if you notice, triangle BEC has a 90-degree angle and a 39-degree angle, which left 51. Well, right next to it, to the left, we have triangle BAE, which has a 90-degree angle and a 39-degree angle. So this angle up here is also 51 degrees. Alright, the only thing I have left to figure out now is I have to figure out this guy. Alright, well, again, I have a right triangle because the diagonals were perpendicular to each other. Alright, and what we've got here is we've got 63 degrees, we've got 90 degrees, so that means I have to do 90 plus 63, and when I do 90 plus 63, that's going to give me 153. So to figure out this leftover piece, I'm going to do 180 minus 153, which is going to give me 27. Well, again, this green triangle that I just highlighted in triangle ECD has a right angle and a 63-degree angle, so that means that this guy is also going to be 27 degrees. So now that I have all of my angle measurements, I can come in here and fill it all in. Alright, now what I want you guys to do on your own, oh, just kidding, we got a couple more we're going to do together. Alright, so again, we've got a kite. Alright, and as you can see, these are the two sides that are congruent, as are these two, which makes angle D and angle B congruent. So that means that these are both going to be 100 degrees. And since this is a kite and it's a quadrilateral and there are 4 sides, all 4 angles are going to add up to 360. So I have the measure of angle A plus 100 plus 70 plus 100 equals 360. So the measure of angle A plus 270 equals 360. So I'm going to subtract 270 on both sides. So I get the measure of angle A is equal to 90 degrees. Alright, now in this kite down here, I want to find x and y. Well, I have the two angles that are congruent to each other marked, so that meant that this side and this side were not congruent. This side and this side were not congruent. Alright, so I look at where all my x's are, and I have x's in 3 spots. And then I have this y over here. So I'm going to have to find x first. So I'm going to say 3x minus 2 is equal to 2x plus 7. So I'm going to subtract 2x on both sides, and I get x minus 2 equals 7. So I'm going to add 2 to both sides, and I get x is equal to 9. Alright, so now I can set these other two sides equal to each other. So I can say 2x minus 12 equals 2y minus 10, but I know that my x value is 9, so I can plug in a 9. So 2 times 9 minus 12 equals 2y minus 10. So 18 minus 12 equals 2y minus 10. So 6 equals 2y minus 10. Add 10 to both sides, and you get 16 equals 2y. So y is equal to 8. Now you're going to do some practice on your own. Alright, so you're going to do this problem filling in the missing measures of an isosceles trapezoid. Then you're going to use this figure, which is also an isosceles trapezoid, and you're going to do 4 through 11. And remember that 4 is a problem, then you erase all of those numbers, and then 5 is a problem, all using this figure right here. And then you're also going to go in here and do problems involving the kite. And then you're going to have a 4th problem, still going in and solving problems of a kite.